Hi, welcome back. I hope you enjoyed the last four lessons. Please let me know if you have any questions or suggestions. Just write in the comment section. In this video, we will look at the prefixes, and I will start with the meter scale, just to revise the centimeters and decimeters. All right, so let's start with decimeters. What is a decimeter? So imagine that you have 1 meter. This is from 0 to 10. Okay. You will see why the 0 and the 10 in a moment, what they mean. But imagine that this length from 0 to 10 there, that makes up 1 meter. Now, if we divide this 1 meter 10 times, then we will have 10 divisions. So 0, 1, 2, all the way to 10. Then each division is called a decimeter, right? So that's the length of 1 decimeter. So this white line here is the length of 1 decimeter. And so then 1 decimeter is equal to 1/10 of a meter. Okay, so please be aware, just remember that when you have a decimeter there, you have a fraction of a meter. And you need 10 decimeters. They make up 1 meter. Okay. All right. So let's look at centimeters, which you probably already know. Right. So that's why I divided that line from 0 to 10, so that I can make 10 divisions to represent what I mean by a decimeter. Right. So in here now, if we further divide 1 meter again, but now we will make 100 divisions. So this is to measure smaller things than a meter or smaller things than a decimeter scale. So then 100 divisions. So that would be that there. There's 100 of that. Okay. So 100 divisions, they make up 1 centimeter. And you can see how small a centimeter is relative to a meter. Okay, so then 1 centimeter is 100th of a meter. Okay, so you divide the meter 100 times. So that means then that you have 100 centimeters is equivalent to 1 meter. Okay, and now let's go further and look at the millimeters. So, but obviously I can't use a meter to divide them, divide it 1,000 times, but I'll rather use a centimeter in this case, and then we'll divide it 10 times. So that would mean then that we've divided the meter basically 1,000 times. Okay, so let's say we have 1 centimeter, this case, not 1 meter, 1 centimeter. And then again, we will divide the centimeter 10 times. Then that means then that 1 millimeter is 1/10 of what? Of a centimeter. So therefore, 1 millimeter is 1,000th of a what? Of a meter. So you have 10 millimeters is equivalent to 1 centimeter, and 1,000 millimeters is equivalent to 1 meter. Okay. Again, the purpose of this is to show the relative sizes. When how does a millimeter compare to a centimeter and therefore a meter? Okay, and we'll do the same comparison using areas and volumes. So let's do that. So in the area, imagine that we have 1 square meter. So how many square centimeters are there in a square meter? In fact, here I just want to show you how small a square centimeter is relative to a square meter. Okay, so imagine this box is 1 square meter. How small is a square centimeter relative to square meter. Okay. I'm just gonna draw this green box here. That's actually square decimeters, and that yellow rectangle there, or yellow square right at the center, that is 1 square centimeter. So that's how small a square centimeter is relative to a square meter. Okay. In fact, you would need 10,000 square centimeters to fill up um, an area of 1 square meter. What about volume? All right. So how many cubic centimeters are there in 1 cubic meter? Let's compare the space in 1 cubic centimeter compared to the space in 1 cubic meter. So imagine this is 1 cubic meter, this blue box here, that's 1 cubic meter. What is the relative size of 1 cubic centimeter? That's not 1 cubic centimeter. That is 1 cubic decimeter. That's a liter. So this red box there, that's 1 cubic decimeters. That makes up a liter. And this is the size of a liter compared to the size of 1 cubic meter. That's how small it is. And that box that looks like a dot there, that is 1 cubic centimeters. That is tiny a cubic centimeter is compared to 1 cubic meter. In fact, you need 1 million cubic centimeters to make up 1 cubic meter. So 1 million cubic centimeters fill up to an equivalent of 1 cubic meter. And so then 1,000 liters or 1,000 cubic decimeters is equivalent to 1 cubic meter. So yes, we define 1 liter to be 1 cubic decimeter, which you will see in chemistry mostly. 1 liter is equal to 1 cubic decimeters. And so yeah, 1,000 liters is equal to 1 cubic meter. And 1,000, of course, 1,000 cubic centimeters, they make up 1 cubic decimeter. So that 1,000 times 1,000, which is 1 million cubic centimeters, they make up 1 cubic meter. Okay, now that is basically the size comparison of meter, centimeter, and decimeters. Okay, lastly, let's look at the amount of substance, a mole, and then we finish off with that. So let's look at the mole. So let's look at the amount of substance, which is a mole. So imagine that you have 342 grams of white sugar. That is swagile. Let's assume that it's made of sucrose, which is the molecule C12H22O11. Now the question is, how many of those particles? So this is a sugar particle. That's C12H22O11. How many of these particles are there that make up this 342 grams of sugar? How many? Well, in 342 grams of sugar, the total number of sugar particles, which is the total number of C12H22O11, is 602.14760.000000000000000. Okay, but that looks like in the order of magnitude is billion trillion. So that is the number of sugar particles, or C12H22O11, that make up 342 grams, which of course, if you've done your stoichiometry, you will be able to figure this out. And I guess you already know what we call this number. We call this number Avogadro's number. So in scientific notation, that's 6,022 times 10 to the power 23. Okay, so it's a huge number. This is a big number. Okay, so it's called Avogadro's number. So that's a symbol Na, is 6,022 times 10 to the power 23, and we name this number as 1 mole. So we define 1 mole to be the number that is equal to 6,022 times 10 to the power 23. All right. Okay. Given this scientific notation and big and small numbers, let's finish off with some prefixes. Why not? All right. Let's look at some few SI prefixes. The purpose of this video is to encourage you to learn to use this first column, which is the prefix, and the names under them. You should, in your calculations, replace these names, or rather the symbols, they normally appear in symbols, with the corresponding factor. Okay, so deca is 10. So dA, what do you see? dA, you see 10 to the power 1. Hecto is 100. So you replace that with 10 squared. Okay. You will see kilo in many calculations. Okay. So instead of asking whether you convert or multiply, but when you go from kilometers to meters, just remember that a kilo represents 10 to the power 3. So then kilo, so in the place of kilo, or in the place of k, if you have km, then you can substitute in the place of km the number 10 to the power 3. Okay, so the 1,000, and mega is 10 to the power 6. Then you have giga. So mega is a million, and giga is a billion, and tera is a trillion. Peta is well, a quadrillion, and exa is a quintillion, right, which is 10 to the power 18. But I think you're most likely going to use 10 to the power 1 all the way up to, I don't know, 10 to the power 9 or 10 to the power 6, depending on the calculations, depending on what's in the curriculum. Okay, so these are the big numbers, all right? So then these are the prefixes for the big numbers. Now let's look at the small numbers, all right? Let me mention that also from mega, that all these ones, mega, giga, tera, peta, exa, they end with A, all right? So the big ones. All right, so let's look at the small numbers, very small numbers. So these are fractional, these are divisions of or fractions. Okay, so let's start with 1. And then we have deci, which you've already seen as a tenth. So deci is 10 to the negative 1. Centi is 10 to the negative 2, which is a tenth, so which is a hundredth. And then milli is 10 to the negative 3, and that's a thousandth. Micro is 10 to the negative 6, that's a millionth. And again, you will see this in electrostatics. For example, when you have microcoulombs, then what you do is to write that in scientific notation. If you're going to do your calculations, in the place of micro, place 10 to the negative 6. Okay, so that's micro. And nano, you may also see that in electrostatics. So you have nanocoulombs or nanometers in electromagnetism for waves. Nano is 10 to the negative 9. Okay, so it's a trillionth. So when you see nano or n, so let's say nanocoulombs, then in the place of nano, you insert 10 to the negative 9, right? 10 to the negative 12, that's pico, which is maybe, those are atomic sizes, atomic radius. That's a trillionth. And then you have femto, that's 10 to the negative 15. That's 10 to the 15th. In fact, the atomic radius, I think it's 10 times the pico numbers there. But femto is 10 to the 15th. And then you have atto, which is quintillionth. That's 10 to the negative 18. Okay. All right. So these are your SI prefixes. Thank you. So now, in the next videos, we will do scientific method. We'll just do independent, dependent variables and interpolation and extrapolation. And yeah, and then we do mechanics. All right. Thank you. See you next time. Bye. Bye-bye.